Alright, in this video we'll go over lesson 10, which is the practice packet, pages 23 to 27. I'll start with question 23. Yeah, I think that makes sense. Alright. Which general trend is found in periodic 2 on the periodic table of the elements that are considered in order of increasing atomic number? Alright, so when we take a look at the periodic table, we're looking at period 2, an ever increasing atomic number just means you're moving from left to right. And what happens with those questions? That's the question. And the answer is the atomic radius increases, increasing ionization energy, decreasing electronegativity, or decreasing atomic mass. The idea here is that as you get closer and closer to fluorine, the top right, you increase the ionization energy. And first ionization energy just means the first electron on the outer shell. 25. The amount of energy required to remove an outermost electron is called the ionization energy, just like we talked about. 27. On table S, which of the following atoms require the least energy for the removal of the most loosely bound electron? All right. Okay, so for 27, the least ionization, we need to go to table S. And look for ionization energy, which is right there. And I'll zoom in here in a little bit, and we'll find the one, and we just need to look for the least energy for the removal. So we need to look at bromine, strontium, and let's just start with those, and I think you'll get the idea. Look for first ionization area, that's the first row, so that's not too hard. And then the first element that we're looking for is bromine, which is right here, element 34. Oh, running out of room here. Element 34. Bromine has an ionization of 1140. The next one is strontium, which is element 38. Element 38, ionization is 549. We want the one with the least, so we could go through all four of those. And if you did, you'd see that it would be strontium with a 538. I'm just having trouble with the highlighter. Here we go. Strontium has the lowest at 538. All right, let's move on to number 29. How much energy is required to remove the most loosely bound electron? Same idea as ionization energy. That's what we want to think about from a neutral atom in a gaseous phase. So the most loosely bound electron from a neutral atom of carbon. So we need to look at carbon. By the way, all of these are in gaseous phase. So looking at carbon, ionization area is 1086, and that's all there's to it. It's just testing your ability to be able to look up numbers on table S. 31. Which sequence correctly places the elements in the course of increase in ionization energy? And for this, I want to reference the reference table, periodic table. And let me zoom out to show you the trend. Fluorine has the highest ionization energy because it has the highest electronegativity, which means it has the most greediness for electrons. And so anything that moves towards fluorine will be the correct answer. So when we take a look at the question, and let me zoom in a little bit. Okay, that was a little bit too much. Oh, actually not too bad. Oh, maybe so. There we go, a little bit better. All right, so anything that ends in fluorine, so what I was going to do is highlight the ones that I think it could be. Could be this one and this one. And the other ones maybe, but we'll double check them. So using the reference to the periodic table, we see iodine, bromine, chlorine, fluorine. Those definitely move towards the correct answer, fluorine being the highest. The other ones you all see do different things, like hydrogen drops around, then beryllium, aluminum, and then gallium, which is way down here. It actually has less electronegativity. So the answer is this one, definitely ends in fluorine. Okay, and then let's move on. 33, oh, there's, I think because I wrote on the last one, which noble gas has the highest first ionization energy? So when we just look at noble gases, you might be able to detect that electronegativity is highest towards the top. So we were thinking maybe helium might, or neon, but we should always double check, especially when we have time on the test. So you just take a look at helium's ionization energy. Helium is 2372, and then we'll look at neon, which is the next one down, and its ionization energy is 2081. So that's 2300 versus 2081. And then if you keep following down to the next noble gas, you'll see that when we go down to the bromine, there's krypton 1351. So far left than 2300. All right, I think that answers that question, that helium has the highest ionization energy. Which number most likely represents the first ionization number in kilojoules per mole of atoms for a non-metallic element? All right, so I think you're starting to get in the hang of it, that the ionization energy increases as you go up, and we saw the numbers. This again is for a non-metallic element, so for a gas, and so I think we just saw numbers like that. All right, I will finish up more on the next page. I'll be right back. All right, let's move on to the next page. This is page 24, and the first question that we'll work on is 37, and we'll be working again through the odds, so you have a chance to work on some evens on your own. What is the first ionization energy of an element that has an electron configuration of 2,8? So you can use your reference table and go to the periodic table and find an electron configuration 2-8, and you'll see it at the very end. And just slide that over. Again, electron configuration 2-8. Sorry, that is neon. That's the key idea there. And then we just need to look up neon. We just need to look up neon on the back page, and it's element 10, and find its ionization energy, which is 2081. So we go back here, ionization energy of 2081. All right, 39. In general, the elements with the lowest ionization energies would be classified as, well, let's again look at the periodic table's general properties, which is that we have greater and greater ionization energy as we move towards fluorine. So the ones that, where was that? Sorry. Would be lowest ionization energy would be considered the metals. If we had to choose any alkali metals, but in this case, metals is all we need. All right. Sorry, I'm just going to find out where that is. Okay, good. So it's option C right there. 41, which element is chemically similar to chlorine? We try to find one in the same group. So we look at chlorine. So we'd hope it would be bromine, but chemically similar, we just look up and down and we see chlorine is closest to fluorine, and so fluorine is the answer. Fluorine. Which group of periodic table contains atoms with a stable outer configuration? 8 is great, so group 8, or also known as group 18. And those are the noble gases. And let me just slide over here. Holy crap. Let me pop. Okay, moving on to 45. The graph below represents the relation between atomic radii, right here, and the atomic number. So we know that this is some sort of element, and then they move forward, and we know they are group 15. So these are all good clues. We can actually figure out which elements they are by looking at group 15 and looking at the lowest atomic number first. So if we take a look at group 15, starts with nitrogen, and group 15's, we know it has to have more and more shells, or in this case, atomic radii is posted. So let's take a look at the question. The graph below represents the relation between atomic radii and the atomic number. Okay, so as atomic number increases, this would have to be nitrogen, and then this is phosphorus, and you'll notice its atomic radius is increasing, acetine, antimony, and then finally bismuth. Which element is the most metallic? The only metal on there is bismuth. All right, let's do one more to finish this page. Which element has the highest electroconductivity? The only metal that you want to look for. Metals, of course, are found on the left and to the left of the staircase, and that's magnesium. Okay, let's go on. Question 49. Is the atomic number of elements within group 2 increases? The metallic character of each successive element does what? Well, again, it doesn't matter really which group. The farther you move away from fluorine and the further down you go, the metallic character should increase. Okay, 51, which element period 4 is classified as an active non-metal? All right, so again, we'll need a reference table for this one. Look at period 4, which is the element of potassium, and you move over there, which one is an active non-metal? Well, here's what it can't be. It can't be krypton because that's not active. It's not reactive to anything. Bromine is the most reactive non-metal. Okay, so bromine. Based on your knowledge of metallic activity, which element should react with water? And we did this as a lab. Alkali metals, group 1 are the most reactive with water. Which are the most active non-metallic element in group 16? So again, we look at group 16, which is the most active non-metallic element. These are all non-metals up to here. So oxygen would be the most reactive. And then 57, which element is more reactive than strontium? So we have to find strontium on our periodic table, and we just need something that either moves, well, it's not too bad. The group 2 element, so the higher up you go, the less reactive, the farther down, the more reactive. So you just look for something that is going to be lower down than strontium, and that's barium. Where was I at? Right here. Good. The most active metals are in group 1. Whoops, sorry. The most active, this 58. Oh, I didn't have to do 58. I was supposed to do 57. I worked all the way around it. Which element is more reactive than strontium? It's going to be potassium. And let me just explain why. Strontium is a group 2 element. Group 1 elements are more reactive. So that's why you choose potassium or element K. All right, let's move on to the next odd problem. 59, represent the correct order of activity for group 17 elements. Means, okay, so obviously greater than, I thought we all knew that, but that's cool. So take a look at group 17. That's these. What's the most reactive one? Fluorine. So we'd really want to look for anything that has fluorine as the most reactive. Oh, where is it? There it is. Fluorine is the most reactive. So these two are promising. And then they should follow the order. It goes fluorine, chlorine, bromine. So fluorine, bromine, chlorine, bromine, iodine. That is the most correct. Which nonmetal is most reactive? It's the one closest to fluorine. In this case, they give you fluorine, so that's fluorine. Down to 63. An element in period 3 of the periodic table are considered from left to right. The degree of non-metallic character each element tends to what? So it doesn't even matter what period it is. If you're moving from left to right across the periodic table, it gets from metals to nonmetals. So you can probably guess it's going to decrease. The non-metallic character, I have to be careful and read this. The non-metallic character increases. The metallic character increases. So I don't go too fast through that problem. All right, now there's some of these questions. I want you to still do the evens. I'll do the odds just to go. Why is it difficult to measure the size of an atom? Because particles are too small, basically. So too small relative to any measurement instruments. Like we can't use a ruler because a ruler is made of atoms, so we can't measure an atom with other atoms. What is ionization energy? It's energy required to remove the first outermost electron. Outermost electron. What trend is evident in atomic radius as you move down elements? All right, as you might have recalled, with each element, as you move down a group, there's more shielding effects. The electrons are held less and less tightly. It increases atomic radius as you go down a group. Define electron shielding. Because kernel electrons on the inside shield the outer electrons out here, they don't feel the same force, electronegativity force pulled into them. So kernel electrons, which means on the inside, like a kernel of corn, shield the nuclear charge from the protons. Okay, when an atom loses an electron, what is its charge? It is negative. I'm sorry, it loses an electron, it becomes a positive. Because the electron is negative, what do you think happens to atomic radius of an atom? It decreases. All right, I think we're pretty much done. Oh, one more. When an atom gains an electron, what is its charge? Gains an electron, it's going to be negative ion. What do you think happens to its radius? It increases. All right, guys, and that is that.